So guys, welcome back to the next video. So in today's session we are going to see how to decide whether a number is prime or not. So I'm going to display three methods here. So out of which the third method will be optimized one and other two methods will work, but it will take more time. So efficiency for first two methods will be less as compared to the third one. So I will explain three methods and you can go with whichever you want. So let me just start my session with the first method. So basically, before going to the program, I just want to tell you what is mean by prime number. Okay, so prime number is something which is having a number is said to be prime if it is not divisible by any other number. So it can be divisible by 1 or it can be divisible by number itself. So except 1 and number itself, if it is not divisible by any number, then we call it as a prime number. So how to write a loop for that one and how to decide how many factors are present. So in first method, what we will be doing, if it is having exactly two factors, then we will call it as a prime number, and if it is not having exactly two factors, so those exact two factors are 1 and number itself. So if you want to know more about those things, then you can just go to our blog over here and you can see we have written almost each and everything for that one. Okay, so I'll just show you. Okay, so I have written each and everything for that one, and also other things like whatever just programming stuff I have written. So if you want to read more about that one, then you can just visit, guys. Okay, so I will leave the link for that in the description. So three ways I have written over here. Okay, so the same three ways I am going to just explain you today's video. Okay, so you can see here three ways to find prime number. So what is prime number? After that, examples, logic to decide a number is prime or not. So you can see a logic means there are three logics, and this is the logic one, guys, and step by step how to what is the algorithm I have written. After that, you can just see the code for that one also from our website also you can get. And logic 2, here also you can see the step by step, and after that code you can see logic 3, and here also you can see this is the optimized logic, guys. Okay, so we will not be checking up to the number itself, we will be checking only up to 10 by number by 2. So n by 2 up to n by 2 only will be running the loop, so number of iterations will be reduced here. Okay, so for that also you can see the code over here. Alright, so this is the for this also, if you want to read in detail, I'll leave the link in description. But for today, I'm going to explain you with the help of code right over here. Got it? So okay, guys, start with the first one. Right, so I need some libraries. So first I will import those libraries, and after that we can start writing the code. So the first line should be the import line, as we know. Okay, so after that, so I'll write here import java dot util dot star. So I will take java dot util dot star so that it will import all the libraries. Okay, so after that I will create a scanner class to take a input from user. So scanner reference variable, I will take it as sc equal to new scanner, and here I have to write system.in. So if you write like this, then it is ready to take the input from user. Now I will just print one message. Okay, so I'll say enter the number. So this will make sure that the number is taken from the user, and whatever the user enters, that I will receive into a variable. Let us say capital N I will take, and I will store that one. Okay, so how to store the number? I can use next int, right? So next int method I will take, and I will store the variable. So once I get a variable, then I will use one counter. So I will initialize it to 0, so that at the end I can check whether its value is equal to 2 or not. Now let us write a for loop. Okay, so for int I equal to, so from 1 I will be starting my loop up to the number itself. For int I equal to 1, I is less than or equal to n, after that I plus plus. So this is my loop, and inside this loop what I want to do, I want to check if the given number is completely divisible by I. That means if it is completely divisible, then the remainder will be 0. So this modulus will basically give remainder. So the number divided by the I value will be starting from 1 and it will be iterating through 1. So any number divided by 1 will be equal to 0. So this will be one factor. And number divided by number, obviously it will divide, and that will be the another factor. So if it is having exactly two factors, then it will be prime number. If it is not a prime, then it might have greater than 2 or less than 2 factors. So I don't know so how many factors, it depends on the number. So if it is exactly 2, then only I will say that it's a prime number, right? So n divided n modulus I is equal to 0. That means it's completely divisible. At that moment what I want to do is increment the counter. So counter, or I have taken count, right? So count equal to count plus 1 I will write. So this will make sure that my count will be incremented each time the number is divided exactly or completely, right? So at the end, outside this for loop, what I will do, I will use another for, and here I will check whether count is exactly equal to 2. So if it is exactly 2, then I will print one message which says like something like this, given, or else I can give like the number is prime. Okay, so the number is prime I will print, and after this what I will do, I will just copy this line, so that for negative condition I will write over here, right? So else I will write, and inside this else I have to write the number is not a prime. So the number is not a prime. So I think this should do my job. Let me just check whether we get some errors or not. So I'll just save this one and try to run. Okay, so in console it is asking for the number. Let me go with first one, that is 5. So the number is prime. Yes, 5 is a prime number. Got it. After that I will just go with and 4 I will enter. The number is not a prime because 4 is not a prime number. So after this what I will do, 2 I will enter. So the number is prime. So it is working fine, guys. And 11 is a prime number. 11 is a prime number. So a test case of like 12 if I take, the number is not a prime number. Okay, so now you will be thinking like, yes, this logic is correct and it is working fine, and why we should go for logic 2 and logic 3. See guys, basically the number of iterations to decide whether a number is prime or not, it is taking 12 iterations. So if you want to check that one, let me just initialize a loop counter. LC I will take it as a loop counter, and I will initialize each time you so each time you increment the counter, or else inside this for loop I will write like loop count equal to loop count plus 1, right? So loop count, each time this for loop executed, so it will mention how many times the for loop has been executed, and at the end I will write over here. Okay, so here I will print loop count. So like I will just write loop count is, and here I will write LC. So that means I want to print the loop count as well. So it is not necessary to be written inside this one, guys. I will remove from that place and place it over here. Okay, so okay, alright. Now you see I will give 10. So the number is not a prime number, the loop count is 10. So that means to decide a number is prime or not, the loop has been executed 10 times. So if it is a small number, then it will be okay, we'll get the output. Let us say 997 I will give. The number is prime, loop count is 997. So this is also a small number, guys. When the number goes in terms of lakhs, then it will take time. So in order to reduce the number of iterations, we will be moving towards next step, that is basically logic 2. Okay, so in logic 2 what we'll be doing, we'll try to reduce 2 iterations. So we know that any number will be divided by 1 and it will be divided by the number itself. So if we don't divide, or if you don't consider those two, that is 1 and number itself, then how many factors will be remaining for the prime number? Only 0 factors. That means you should not have any factors if you don't consider 1 and number itself. Listen it carefully, guys. If we don't consider number itself and 1, then it will be left with 0 factors because it is not divisible by any other number. So at that moment what I will do, I will start the loop from 2 and I will not go up to n, I will go lesser than n. So in this situation my loop count will be somewhat less as compared to the previous one. So if I give 997 again, then you can see it is giving the output properly. The number is not a prime number and the loop count is 997. So it is taking less iterations. Two less iterations as compared to the previous one. So for this also I can still improve with the help of one break statement. So we know that if here I need to change the condition, guys. If loop count is equal to 0, then it's a prime number, else it is not a prime number. So I will just run this one again. Okay, so 997, and you can see this is the prime number and number of iterations it is taking is 995. So if I mention something like this, if count, okay, so if count is, I have to mention like this, if, and here if count is greater than 0, which means it's clear indication that it's not a prime number. So then I will write break here. So you understood this one, guys. Like if the count goes beyond 0, then whether it may be 1, 2 up to n, so it may have any value, then it's clear indication that it's not a prime number. Then why I should check for all those conditions? So the moment the count value goes beyond 0, I will write break. So this will make sure that this for loop will be breaked. So this will stop the execution at that point itself. So for this number of loop counts will be very less and the efficiency is going to increase. So let me just run this one and show you the output. 997 I will give again, and you can see it is taking again 995, and if I give like 10, so you can see the number is not a prime and the loop count is 1. So in one count itself it is telling that it's not a prime number. So let me just take 125. So in 4 loop counts it is deciding 125 is not a prime number. So this is the power of the block which I have written, guys. So you can see previously it was taking 125 iterations to decide whether a number is prime or not. After that we have reduced 2 iterations, and after that we have reduced it to a greater extent, around 5% it is taking now, as compared to the 100% whatever it is taking, right? So still I can improve this one with the help of n by 2. Here I am trying to, but this is for not a prime case. But if I check for prime, that is if I give 997, you can see still it is taking 995 number of it is taking 995 number of iterations, right? So in order to do this one, or to reduce the iterations, I need to go for third logic, and I should explain third logic, guys, then only you will understand the code. So I will just try to open Paint over here. Okay, so Paint, and with the help of marker I will try to explain. Just bear with me for just 1 or 2 seconds. Okay, so first what I will do, I will find the factors for 4. So factors for 4, and I will not consider 1 and number itself. So apart from 1 and number itself, or else I will consider 1 also. So one of the factor, 1 will be definitely factor for any number. After that it is completely divisible by 2, and 4 I will not consider. Every number will be divisible by the number itself. So that's why I will not consider. And if I consider 8 here, so for this 1 will be the factor, after that 2 will be the factor, and after that 4 will be the factor. So if I consider similarly 12, So 1 will be the factor, after that 2 is a factor, after that 3 is a factor, after that 4 is a factor, after that 6 is a factor. So the point which we should note over here is that if I divide 4 divided by 2 will be equal to 2. 8 divided by 2 will be equal to how much? 4. 12 divided by 2 will be equal to 6. So the meaning why I am writing here is just observe the highest factor. So here it is 2 and in this case it is 4 and in this case it is 6. So it is just for 3 examples. So if you take any other example, it will follow the same rule. So the main thing which we should focus is the highest factor will be within 4 divided by 2, that is 2. So for this the highest factor is within 8 divided by 2, that is 4. And for this the highest factor is within 12 divided by 2. That means I should not run the loop until n. So until n means whatever number we have mentioned. You just need to run the loop until n divided by 2 because the highest factor will be within this limit. So more precisely I can say you have to write like this, square root of n. So if you take square root of n and you have, it will be basically same, or I can say similar, not exactly same. So the square root and the n divided by 2 values will be somewhat similar, or more precisely I can say they are close to each other. So run loop up to square root of n, don't run up to number n itself, so that the number of iterations will be reduced and your program's efficiency is going to definitely increase. So how to do that one, let me just show you. So I will just erase these things and now I will write the final logic where the loop will be modified in such a way like this, where I should be, and what I need to write is like I have to use here another function called math.sqrt. So I should be less than or equal to math.sqrt of n. So math.sqrt of capital N. If I write like this, so this will make sure that my loop will be running up to math.sqrt of n, right? So and the rest of remaining logic remains the same, like if count is greater than 0 then I need to break, and if n divided by 2, and if the count is 0 then it's a prime number, then in other case it is not a prime number. You just need to change the upper limit here, and here the iterations will be starting from 2 itself because I don't want to consider 1 because I have written logic count is equal to 0. That means it should not have any factor at all, right? So let me just save this one and try to run. Okay, so for 997 itself I will show you 997, and you can see this is a prime number and number of iterations is reduced to 13. Before it was taking 995, right? So before it was taking 995 and now it is decided with the help of only 30 iterations. So from that you can understand that. So the logic 3 whatever we have written over here is having a higher potential towards reducing the execution time. You can take any time, any number guys. Let me just take 125 whatever we have taken previously. See, only 4 iterations it will take. Okay, so randomly I will enter some number and you can see the number is not a prime number, and within 96 operations it has decided that is 17,363 is not a prime number. So this is how you can optimize the logic. So whenever you are writing in real life or in any project, try to implement with the help of this logic itself because it's optimized one. Otherwise, if you don't want to take tension, I mean there is nothing like taking tension in this one guys. Previously you were writing I is less than or equal to n. You just need to insert this math dot square root of n, and for that I have already shown you the logic why you should write that one and all those things. Okay, so if you want to get step-by-step explanation, definitely I recommend you to visit our blog guys, and you can see if you want to get the code also, I have pasted the code here itself. You can directly copy from here and you can run it in your ID. So that's it for today, guys, and I hope you understood the things. So follow for more. Please do subscribe the channel and have a nice day. See you in the next one.